Whoa, nice mullet. Wish I had one like that. Well, anyway, we're going to continue solving linear equations. We're going to apply what we know about equations, and we'll take what we know about that and apply it to uh, a new thing known as ratios and proportions. We'll learn what a ratio is and how we can apply what we know about equations to proportions. As you can see with the guy with the cool mullet, a ratio in this case compares the business to the party of the mullet. Okay, a ratio is a way we can compare two quantities and give it a value, so we can compare. In this case, compare someone's mullet and say who's got the better mullet. So we'll take a look at ratios and how we can do that. Another thing that we take a look at with this is, as we're comparing two different things, what gives us the better deal? We need to set up a ratio or a proportion to do that. Or let's say you go to the store and there's a price for apple juice, a 6-pack. Let's say I only wanted 5 of those. How could I find the value of 5 apple juice containers? Or similarly with a 4-pack of blueberry soda, let's say I only wanted 3. How could I find the price? Ratios and proportions help us with that. Crazy store, I know. You pick and choose what you want, but if that were possible, some places it is, how do you find the value of that? So we'll use ratios and proportions to help us do that. Okay, so let's get the basics of what a ratio is before we dive into that. You might know some of this already, but let's put it down on paper so that we have it. A ratio. Ratio uses division to compare two quantities, as I mentioned before. Think of the mullet, business to the party. We're using division in that. We're comparing the two quantities. Say, for instance, we have two quantities, A and B. B is not 0 because it's nothing. We would have nothing to compare to. And once again, we can't divide by 0. So we can write those multiple ways. We can write A to B using fraction bar, or the division symbol. We can say A to B using a colon. And we can also say A to B. Okay? So 3 different ways that we can write that. But in the same way, we read those all the same way. It's the ratio of A to B. That's what all 3 of these say, the ratio of A to B. Okay? And if possible, each ratio should be written in simplest form. Just makes things easy to compare when they're all in their simplest form. Okay, so let's take a look at an example of how we can write a ratio. Let's say, for instance, a few years ago, the Shoreland volleyball team played 7 home matches and 21 away matches during the regular season. If we want to find the ratio of home to away matches, we're comparing home to away. So we take a look. 7 home, 21 away. So we'd say 7 to 21. I'm just going to write that as a fraction over here. 7 to 21. And since those numbers are fairly large, and we see they're both divisible by 7, we can say, well, that's 1/3 is the ratio of home to away. I can write 1 to 3 or 1 to 3. Okay, so we can see they play 3 times as many away matches as home matches. And so when we have that ratio, we can compare that a little bit easier. Ratio of home to all. Well, now we're getting 2 quantities. The first quantity is home matches. Well, there were 7 home matches. And all together, they played 28 matches. I see those are both divisible by 7, so that gives us 1 to 4. The ratio is of home to all is 1 to 4. So we can see that 1 out of every 4 games was home. So they're kind of being gypped out of the playing in front of the home crowd. They should talk to their athletic director and try to figure things out so they get the home crowd on their side. Okay. Now, proportion. A proportion is something that we take a look at. A proportion is basically an equation. It's an equation stating that 2 ratios are equal. So we're basically taking two ratios. So say, for instance, the ratio of A to B is the same as the ratio of C to D. Okay, to use variables. Or, if we want to use specific values, we could use that value we used before. So 7 over 21 is equal to 1/3. Okay, those two ratios, 7 to 21, is the same as the ratio 1 to 3. 1 to 3 is just the simplest form of that. So this equal sign just says that those two ratios are equal. So it's helpful now when we take a look at one of these examples. The ratio of x to 15 is the same as the ratio of 3 to 5. So we know that those two are equal. Okay? Multiple ways we can take a look at this. One way is by looking at the equation. Well, x is divided by 15. How do I get rid of dividing by 15? I multiply both sides by 15. When I multiply both sides by 15, I get x equal to, multiply my fraction here, 45 over 5. 45 divided by 5 is 9, so x equals 9. So that's one way to solve that. Another way is just to take a look at the ratios themselves and see if you can find a connection. Think of putting it in the simplest form. So 15 down to 5, we see that number is divided by 3. So x would have to be divided by 3 to get to 3. So that would have to be 9 as well. So you can look at the connections within the proportion if you're able to do that. When the numbers get a little bit bigger, like this next example here, x to 144 is the same as 4 to 32. You might be able to see that connection between 4 and 32, that it's 8 times bigger. So I'd have to know that 144 is 8 times bigger than x. And if you recognize that 144 is 8 times bigger than x, you just divide 144 by 8, and you'd see that x is 18. Okay, so that'd be one way to do that. The other way is to look at it as an equation again. X is divided by 144, so multiply both sides by 144. And when we do that, we get x equal to 4 times 144 is 576 over 32. 576 divided by 32 is 18. No matter which way you look at it, you'll get that value. Okay, so why don't you try that next example in the corner down here. Okay, maybe you saw the connection that 25 is 5 times bigger than 5. So 45 had to be 5 times bigger than n. So n had to be 9. Okay, if you didn't see that connection, you'd have to solve the equation. So you're solving for n. You have to get n by itself. But notice n is on the bottom being divided by n. So I'm going to multiply both sides by n. Okay, so now I have 5 equals 25 45ths times n. Now to get n by itself, I multiply by the reciprocal, which is 45 25ths. So multiply both sides by 45 25ths. Cancel that out. And so now I have 45 times 5, which is 225 over 25 times 1. That equals all I have left with over here is n. 225 divided by 25 gives me 9. So notice either way will give us the solution. If you can pick out the connection, it's maybe a little bit quicker than solving the equation, but you'll find that solving the equation is something we'll need to do on some of the more complex proportions. Okay, well, let's just practice how to write proportions. So 3 is to 8 as x is to 32. Okay, we would write that one in that way. Number 2, x is to 4, so we're comparing x to 4 in the same way that 8 is to 16. Okay, and then number 3, b is to 10, so b to 10 is the same as 7 to 2. Okay, I want you to take the time to solve those equations for their variables. Pause the video and start it when you're ready. Okay, I've taken a look at how to show those just by looking at the connections between the ratios. 4 times bigger, so x is 12. These numbers are twice as big on the bottom, so this has to be 2. If I go backwards, this is 5 times bigger, so b has to be 35. By no means is that the only way how to solve it, but I was able to find the connection in that way. Okay, elevators. Let's take a look at that one. So the elevator takes a passenger from the lobby of the John Hancock Center to the observation level. It travels 150 feet in 5 seconds. That's its ratio. That's how fast it is going. The observation level is located on the 94th floor at 1,029 feet above ground. How long will it take the elevator to travel from the lobby to the observation level if it's going the same rate? So let's make a comparison. We're comparing feet per second. And so we know if we're going 1,029 feet, we need to know how many seconds that is. So notice we've got a proportion. This one, we've got to make that comparison and figure out how many seconds. Why don't you see if you can figure out how many seconds that will be. Okay, so since I was just comparing the values, I made an equation, set a question mark, x seconds, I put x. And so I took a look. As I went from 150 to 1,029, I found that that was 6.86 times bigger. So I multiplied 5 times 6.86 to get 34.3. Maybe you looked at the connection between 150 and 5 and saw that it was 30 times bigger. So maybe you just took this number and took the 1029 and divided it by 30 to get 34.3. Either way works. Maybe you solved it using an equation. Okay, let's take a look at a few more, a little bit complex proportions. So 6 is to b as 3 is to b minus 2. Now, as we're comparing, we see, well, 3 is half as big as 6. So I know b minus 2 has to be half as big as b. Okay? So since we're comparing those, there's multiple ways we could look at that. But probably the one that would be the easiest to follow would be, let's just use this equation and what we know about solving equations. So 6 to b equals 3 to b minus 2. Well, I know if I'm solving the equation, I need to get the b's alone on one side. So let's get rid of the fraction bar. So 6 is divided by b, so let's multiply both sides by b. Okay? So now I have 6 equals 3 times b over b minus 2. Now, I'm dividing by b minus 2, so I'm going to multiply both sides by b minus 2 to eliminate that. So multiply by b minus 2 over on this side as well. So I have 6 times b minus 2 equals 3b. So I can distribute 6b minus 12 equals 3b. Get the x terms alone on one side. So in this case, the b terms. So I'll subtract 6b. We get negative 12 equals negative 3b. Multiply or divide the answer you'll find. So divide by negative 3. b is 4. Now check. So 6 to 4. And that ratio needs to be the same as 3 to 4 minus 2 is 2. 3 is half of 6, 2 is half of 4. So it works out. Why don't you take a look at this next problem, see if you can solve that one. Pause it and start it again when you're ready. All right, so taking a look at the equation, I looked at the left side first. It was divided by 3, so multiplied both sides by 3. I distributed that 3 to this expression, 2.7 minus 3t. Then I needed to divide by negative 5 over here, so I multiplied both sides by negative 5 and distributed that. And then I got the t terms alone on one side, so I added 82.5 to both sides. So I had 85.2 minus 3t equals negative 15t. Then I added the 3t so that my t's were on the same side. Divide by negative 12, t equals negative 7.1. Okay, so that's how you solve a proportion where there are variables on both sides, just like solving an equation. So we've taken a look at how to write a ratio, what it means, how to solve those proportions, and then how to solve a proportion by following the same rules we use for solving equations. We got practice problems and application. We'll see you next time.